Hey guys, my name is Austin Harris, and I'm here to present Jonathan Kuhn and I's MECH 6970 final project. For this project, we decided to make a smoker controller, and so basically our thoughts behind it were when you're cooking barbecue and you need to control temperature for a pork butt for 8, 10, 12 hours, it'd be nice to have a way to control that temperature so that you're not having to stay up all night with it. So what we decided to do was use a big green egg that controls heat based on intake, air intake and air exhaust, and decided to use a DC motorized fan to control that. So basically the whole idea behind it is if the temperature is too low, we push air in, and if the temperature is too hot, then we can pull the air back to reduce temperature. All right, so now I'm going to go a little bit into each of these components that we use for our project. So the first is the sensing component. For that, we used a temperature probe that is a thermistor, and so that gives us the temperature inside of the big green egg, and that is used to give information to our Arduino controller that is doing all the computation for our PID controller. And that controller is driving a DC motorized fan, a 12-volt fan that's pushing air into the big green egg. And for our mechanical design, we did a 3D printed housing for our electrical components that is heat resistant.
All right, and now we're going to go into some of the details of the actual project. Like Austin said, our material is heat resistant. It can withstand up to 200°C, and based on our tests, it's done fine. It hasn't even gotten soft, so that's really good. The project is controlled by a Arduino. I think it's a Pro Micro. Of course, as you can see, you have a user interface here with a screen displaying the set temperature, your actual egg temperature, and then the fan speed as a percentage of its maximum. You also got some user inputs, and we'll go over that in a minute. For now, I want to show the inside of it. So right here's the Arduino, and we got our circuit board. Got a MOSFET controlling the fan right here. You also have some power conditioning stuff, making sure it's the right voltages. You know, your header going to the screen and whatnot. And over here, we got 4 different spots for temperature probes. Right now, we're just using one, but ultimately, you'll be able to have multiple probes inside the grill, as well as some meat probes outputting to the display. You can see here we got our brushless DC fan motor. It's rated for 12 CFM, which based on our initial studies should be more than enough. We did some tests, and the maximum needed for the egg was 10 CFM, so we should have everything we need, and our tests have shown that. Right here, if you look a little closer, you got the fan, and it goes into a channel that goes directly into the egg, interfacing with the egg's stock damper system. This slides right in. So yeah. All right, now we're gonna show how to set the temperature and get this egg going. So come here, the default set temperature is 330 degrees Fahrenheit. But to get into set mode, you just hold down the menu button, and then you can adjust your set temperature. We're actually going to go to 280 degrees for our grill today. You just press the menu button again. It saves your set point, and now it's starting to control. So we're out right now. We're hooked up to our Arduino IDE, and we're going to be plotting our outputs on the plotter there, so we can kind of get a live view of what's going on. It'll take a few minutes, so we'll show you kind of once things get going.
All right, so while this egg is heating up, we're going to go ahead and talk a little bit more about our controller that we decided to use. So we implemented a PID controller on the Arduino, and so to get our gains, we decided to do a manual tune, and so we spent a whole night pretty much just running the egg at a certain temperature and seeing how well our controller worked and adjusting our gains based off of that. And to do that, we needed to have an understanding of what each gain controlled. So the proportional aspect of the controller is proportional to the temperature error from what we set the temperature of the egg to be and what our temperature probe is reading. And the integral component is related to the accumulated error of temperature over time. And so there's actually a really interesting problem that we had with that, where if our temperature was too far off while the egg was coming up to temp, it would kind of spool up the error and then it would way overshoot. So we actually had to put a little if statement where it would only count towards the accumulated error if the error was between the bounds of our fan's capabilities, and that helped solve that problem. The D portion of the controller is related to the rate of temperature change of the temperature inside the egg. And so yeah, we kind of just took a night and manually tuned our system. Right here I'm going to show a plot of where we were tuning the I portion of the controller. So you can see here on this plot, it gets up to a temperature. We had set it at 310 and it settled out right at about 309, and it was pretty close, but we noticed that there was a little offset error. So to account for that, we increased our I by a certain amount. I can't remember, but we increased our I and then retried it. Noticed it didn't get quite up to where we wanted it to, and so increased our I some more and got right at 310 just like we wanted to. And so after our whole tuning process, you can see our final plot showing us getting to a temperature of 275 degrees Fahrenheit. And you can see this linear part of the plot is when the fan is pushing at 100%. We have maxed out the airflow that our fan can produce, and so it is just increasing as fast as it can. But we felt pretty happy with this overshoot and rise time, and it settled right at 275 and held really well.
All right, so the egg is up to temperature. As you can see down here on the readout, our set temperature is 300. Our egg temp is 302, 301. It's kind of modulating, and the readout's has some errors in it, but the fan speed's around 20%. So if you come look at the graph, you can see the roll up. So this is the temperature plot. I cut some of it off so it's easier to see, but you can see here that our set point is right here at 300, and you can see it is leveled off pretty well right at 300. Very little overshoot. Looks like maybe we're in a little bit of an overshoot right now, but the integral error will take care of that in a couple minutes, and we're only a degree or two over the set point. So for the purposes of a smoker, that you really couldn't ask for much more. The default temperature probes on these things aren't even that accurate. So we'll show it working. We'll kind of show over time and where it ends up. But here you can see some of the errors that we've encountered that maybe in the future we might try to remedy. You can see the temperature plot's kind of jagged. That's likely due to the noise on the thermistor, the thermal probe. We think that is mainly due to the resolution of our analog digital converter. So there are higher bit converters out there that would probably help with that. The thermistor calibration curve is a logarithmic graph, so there's quite a bit of resistance swing on those. Yeah, and these sudden changes due to the reading affect our differential readings quite a bit. So one of the things we did to kind of even that out is we did a moving average of our temperature, just so our differential wouldn't swing by such large degrees. You can see it now. It's kind of leveled off here. I would wager it's going to go down over time. We'll see what it does. Worst case, there's a little bit of offset error. You can't get your gains perfectly tuned. But over time, you know, we can tweak this, and but honestly, it's within a couple degrees at the set point. That's pretty darn good. All right, our apologies. We kind of stepped away for a second, and it looks like our serial plotter started cutting off our data, but we're getting the kind of tail end of it here. You can see right here we're at 303, and right here we're settling to about 301, almost 300. So before, what it cut off the graph was it coming up to temperature, and this 303 is a little bit of overshoot, which really, I mean, 3-degree overshoot is really pretty good. So I'm happy with that because it allows it to get to temperature quicker. But as you can see, it's 303 is coming down as the integral part of the controller starts accumulating error. It's slowly finding that perfect offset that it needs to be at. You can see it reaching it there. So, all right, we're putting some jalapeno poppers on. So we've reached steady state on the graph, so we're gonna put these guys on. We'll show the graph. You should see a nice dip as he's let all the heat out, and you should see the grill get right back up to temperature, you know, within a few minutes. All right, so you can kind of see here, you can see us opening the grill. That's when we put the jalapeno poppers on. Get quite a good temperature dip. Then you see it coming up and reaching a steady state. Looks like, again, we have just a little bit of overshoot. Maybe we could adjust our gains in the future, but that's still pretty good. You know, hopefully over time that integral control, accumulated error, will account for that small offset. I mean, it's only a couple of degrees. But yeah, another example of working.
All right, so we have been on for about 45 minutes or so cooking these jalapeno poppers, and you can see right now the temperature is settled out to right around 301. Our set temperature was 300 degrees, so it does look like there's a little bit of an offset error, but we're still well within 1% error, so we're pretty happy with that. All right, so you can see here we've been on for probably 15 minutes since we've opened the lid. You can see here this drop where the temperature kind of bottomed out. Once we closed it, it's been steadily coming back up to temperature. You can see we have a pretty well damped system. It's pretty close to critically damped, just looking at it, but it's evening out right around 300. There's a slight bit of overshoot, which is great, and yeah, evened right out to 300. So we're very happy with this performance. All right, so our jalapeno poppers are done. They cooked for about an hour, right at 300 degrees. So it turned out really well. Smoker controller works great. This was a really fun project for Jonathan and I. Really enjoyed it. Learned a lot. Feel like there's a lot of improvements that could have been made, but overall we are very satisfied and very proud of the work that we did on this project, and look forward to continuing to use this on the weekends.